So now we are going to understand a very important part, that is types of organic reactions. So whenever we carry out any organic reaction, it could be classified into 5 main types. They are substitution, addition, rearrangement, elimination and a condensation reaction. Let us understand one by one. Substitution reaction, I have an example of CH3Cl, methyl chloride, being reacted with aqueous KOH to give methyl alcohol and the byproduct KCl. So in this reaction you observe that OH from the KOH substitutes the Cl, thereby converting a chloride into an alcohol. So this type of reaction, when one functional group gets substituted by another functional group, is called a substitution reaction. Now in this substitution reaction, if you observe KOH, it will break down as K plus and OH minus, thereby generating the OH minus as a source of nucleophile, and this nucleophile is substituting the Cl, which also has a negative charge, meaning a source of nucleophile. Hence, it's a reaction where a nucleophile is substituting another nucleophile. Hence, this reaction can be called as a nucleophilic substitution reaction. So, nucleophilic substitution reaction involves the substitution of one nucleophile by another nucleophile. Likewise, we can also have electrophilic substitution reaction, where one electrophile, a positively charged species, substitutes another electrophile, that is electrophilic substitution reaction. And third type, we can have free radical substitution reaction. Shortly, I'll call it as FSR, wherein one radical would substitute the another radical. So, whenever we talk about substitution as the main type, you should always think about the 3 other subtypes as NSR, ESR, FSR. Full form: nucleophilic substitution reaction, electrophilic substitution reaction and free radical substitution reaction. Second one, addition reaction. The example here is ethene and alkene added with Cl2. Since double bond is a combination of sigma and pi bond, and a pi bond is a weak bond, the chlorine molecule here gets added across the double bond, thereby breaking the pi bond to convert it into a single bond. So whenever a reagent gets added across a multiple bond, can be a double or a triple bond, those type of reactions are always called addition reactions. A reagent added across the double bond to form a single bond is an addition reaction. Now the addition will also be classified into the 3 subtypes as a nucleophilic addition reaction if the reagent added is a nucleophile, or a electrophilic addition reaction if the reagent added is electrophile, and a free radical addition reaction if the reagent added are free radicals. So this can be shortly called as NAR, year and far reaction. So whenever we talk about addition reaction in organic chemistry, again think of the subtype as year, NAR, far, NAR, year, far. Third type is rearrangement reaction. Now rearrangement reactions are those in which one of the atom or group of atom migrates to another atom to obtain stability. Example, if you see here vinyl alcohol, CH2, double bond CH and OH is highly unstable. So unstable species in organic are represented by a square bracket. So being unstable, it will try to stabilize itself. For that, the H from the OH migrates on the double bonded carbon, thereby changing this to CH3 single bond CH double bond O, that is a stable compound of acetaldehyde. So rearrangement reactions are the concept of stabilizing the unstable reactant to a more stable product, wherein the migration of an atom happens to another atom, thereby changing the double to single and single to double bond. And also, whenever a rearrangement reaction happens, the molecular formula of the 2 compounds would obviously remain same, because there is no addition or elimination happening to it. It's a just rearrangement, adla badli reaction, where one atom is migrating to another. Next, elimination reaction I can say is simply the reverse of addition reaction. In elimination reaction, if I see, the single should get converted to a double bond. So that's what is happening here. I have an alcohol compound heated with concentrated H2SO4, a very strong dehydrating agent. The H and OH eliminates as a water, thereby converting this single to a double bond. So reactions involving conversion of single to a double bond, a formation of a pi bond, are called elimination reactions. Next coming up is condensation reaction. A condensation reaction could be simply defined as a sum of addition and elimination reaction. Matlab, it is a reaction in which addition and elimination takes place simultaneously. So the example is acetone reacted with H2NOH, that's hydroxylamine, in acidic medium, where O takes away the H2 to form a water, and at the same time carbon bonds to nitrogen, meaning water eliminates and carbon adds to nitrogen simultaneously. Hence, the reaction in which the addition elimination happens simultaneously are called condensation reactions. So totally, whenever we talk about the type of organic reactions, the 5 types are substitution, addition, rearrangement, elimination and condensation. Condensation is just a subtype of addition elimination. So if I talk about the main types, they are just substitution, addition, rearrangement and elimination. So I summarize this type of reaction as SARE. SARE, SARE reactions. All reactions of organic can be just classified and remembered as SARE. C is just A plus E, addition and elimination simultaneously. Now, under substitution and addition, I said that there are 3 types each, and that types are depending on the species, that is the type of the attacking reagent. It can be a free radical or electrophile or a nucleophile. Free radical is Fr, electrophile is E and nucleophile is N. So it can be a free radical substitution, free radical addition, electrophilic substitution, electrophilic addition, nucleophilic substitution or nucleophilic addition. So this friend can be remembered as friends, meaning the type of organic reaction simply should always be remembered as SARE friends. SARE friends indicates the main type of the reaction and friends indicate the subtype of the reaction only for substitution and addition.